this section of Chapter 1, we're going to cover organic functional groups. Organic functional groups are atoms within a molecule that have characteristic chemical behavior. And what we're going to see with these functional groups is they are going to dictate the reactivity of many of our organic molecules. You do need to memorize all of these organic functional groups. So I would recommend during this time to make some flashcards associated with these functional groups and make sure that you can not only name them, but recognize them as part of a structure as well. The first one is going to be an alkane. Alkanes are going to be carbon-carbon single bonds. So anytime you see carbons connected by single bonds, we're going to refer to these as alkanes. The next are going to be alkenes. Please notice the change from the A to the E. So these are alkenes. Alkenes are going to be structures that contain a carbon-carbon double bond. We then also have alkynes. Notice once again the small change with the Y. Alkynes are going to be structures that contain a carbon-carbon triple bond. So this would be an alkyne. We're also going to see an aryl or an aromatic ring. These are going to be a ring of 6 carbon atoms with alternating single and double bonds. And then we're going to see a variety of different connection points. So what you'll notice on all these structures, I have left some bonds open. Those open bonds can be bonds to other things. Typically they are going to be hydrogens unless otherwise denoted. The next is going to be an alkyl halide. For an alkyl halide, this is going to be a carbon atom attached to a halogen. Those halogens can be things like our fluorine, our chlorine, our bromine, or our iodine. So this is going to be an alkyl halide. Those halogens will typically contain 3 lone pairs. The next group is going to be an alcohol. For an alcohol, we have a carbon that is bound to an OH unit, and it is that OH unit that is making the alcohol. The oxygen is bound to a carbon and bound to a hydrogen and 2 lone pairs. The next is going to be a thiol. A thiol is similar to an alcohol. The only change we are going to see is instead of having an oxygen, we're going to have a sulfur. So this is where we have sulfur connected to a carbon and a hydrogen, and it is a thiol. The next is going to be an ether. In an ether, we have carbon that is going to be bound to an oxygen, but that oxygen is going to be bound to a second carbon atom as well. So in ethers, we have oxygen atoms sandwiched in between 2 carbon atoms, and this is an ether. The next is going to be an acetal or a ketal. In these acetals or ketals, we have a carbon that is going to be attached to 2 OR units, as well as 2 other carbon chains. So I'm using a new abbreviation of an R. R's are typically going to be other carbon chains of any length or of any branching. So anytime you see this R functionality, you just want to think about it as some generic carbon chain or a chain of carbon atoms. The difference between an acetal and a ketal is going to be this R unit attached to that oxygen. In the acetals, the R unit on the oxygen, that R is typically going to be a hydrogen. For the ketal unit, that R is typically going to be a carbon chain. So we'll see with both acetals and ketals, they have similar functionality for us. But the key here is we've got a carbon that is in between 2 oxygen that is attached to other units as well. We can also have a hemiacetal or a hemiketal. Our unit here, we're still going to have our carbon in between 2 oxygens and 2 other carbon atoms, but one of those oxygens is going to be defined as an H. One of them is going to be defined as an R unit. So these are hemiacetals that we're going to be looking at. A carbon in between an OH and an OR unit. We can also have an epoxide. Epoxides are when we are going to have a 3-membered ring. Two of the members of the ring are going to be carbon atoms. One is going to be an oxygen atom. So this is an epoxide, where we have a three-membered ring. One unit is an oxygen, and two of the units are going to be carbons in this nice ring. So this is an epoxide. We are also going to have our amine. In amine functionality, we have a carbon bound to a nitrogen. That nitrogen will have two other attachments associated with it. They can either be hydrogens or they can be other carbon atoms. But the amine has a carbon and a nitrogen bound together. We also have a nitrile group. For our nitrile group, we have a carbon that is triply bound to a nitrogen. So this is our nitrile. It's a CN unit when we talk about the nitrile, where we have a carbon and a nitrogen triply bound together, and that would be connected to our carbon chain. We also have a carbonyl. A carbonyl is some generic functionality. We're going to talk a lot about different types of carbonyls. In a carbonyl, it is a carbon that is doubly bound to an oxygen. This is a very generic functional group. We're going to talk some more specificity here shortly. And you really want to define groups based on this specificity. It is very rare that you will use this generic carbonyl nomenclature, but you do want to be familiar with it. But it is not something that we would typically identify in the structure. For the specific types of carbonyls that we can have, one of them is going to be an aldehyde. In the aldehyde, we have that carbon-oxygen double bond, but the carbon is specifically going to be attached to a hydrogen and then a carbon chain. So this is the aldehyde, where this is the specificity that you would want to identify within an organic structure versus just labeling this as a carbonyl. It is specifically an aldehyde. We also have ketones. In our ketones, we still have that carbon-oxygen double bond, but this time the carbon is attached to two R groups, or two other carbon atoms. So this is a ketone. We also have a carboxylic acid. In our carboxylic acid functionality, we still have the carbonyl, the CO double bond, but the oxygen is attached to an OH. So this is a carboxylic acid. We also have an ester. In our ester, we still have the carbon-oxygen double bond, but the carbon is attached to another oxygen atom, which is attached to another R group or another carbon chain. So this would be an ester. We have the carbonyl, but the carbonyl is attached to another OR unit. So this is our specificity of an ester. We also have an amide. In an amide, we still have the carbonyl unit, the CO double bond, but it is attached to a nitrogen. That nitrogen can be attached to other hydrogens, or it can be attached to other carbon atoms. So the nitrogen attachments can be either carbons or hydrogens, but the key with the amide is we have the carbonyl, and that carbonyl is specifically attached to a nitrogen. So again, these are all the functional groups that we will be looking at this term and next term in organic chemistry. You want to make sure that you are starting to memorize all of these functional groups so that you can identify them in organic structures.